Hey guys, now we're going to talk about motion. One of the first types of motion we're going to talk about is speed. Now speed measures a change in distance over time. And we have a formula for that, which is speed equals distance divided by time. And we can use our favorite formula triangle, the STD triangle, to solve these problems. Don't forget with your triangles, top and bottom divide, side by side multiply. An example of speed would be something like a car driving 60 kilometers per hour. Now notice kilometers is distance and hours is time. We have distance divided by time. When we have speed and we add direction to it, we get something called velocity. Velocity measures speed in a given direction. So an example of this would be the car driving 60 kilometers per hour west. Your key word with velocity is direction. If you take velocity and add time to it, you get something called acceleration. Acceleration measures the change in speed or velocity over a period of time. And acceleration, we can have something called positive acceleration, which is where we have an increasing speed. This is probably what you think of when you think of accelerating. The car went from 0 to 60 in so many seconds. That's a positive acceleration where it's getting faster. But there's also something called negative acceleration when you have a decreasing speed. And this would be like when I'm driving to work in the morning and I come up to the school zone and I have to hit my brakes and slow down. My slowing down is accelerating, but accelerating negatively. The last thing with acceleration that we're going to talk about is accelerating when you have a change in direction. So here we have a car driving on a circular track, and it's going at a constant speed of 20 kilometers per hour. Its speed is not changing, but this car is accelerating because it's constantly changing direction. A change in direction can also mean acceleration. Now we're going to go through a couple of practice problems. I'm going to do number 1 with you. I'm going to help you set up 2, 3, and 4, and you're going to work with your partner to solve 2, 3, and 4. Let's look at number 1. Some students were investigating the speed of a toy car they built. They performed 2 trials and recorded their data in the table below. What was the average speed of the toy car during the 2 trials to the nearest tenth of a meter per second? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. Now, when we're looking at this question, they're asking us about average speed, and they've given us information in the table. Time is 4 seconds and distance 5.6 meters for trial 1. For trial 2, we have time is 5 seconds and distance 7 meters. So what we're going to do for trial 1 is start with our STD triangle. We are looking for speed, and they've given us time and distance. Our time was 4, and our distance 5.6. So now we need to decide if we're going to divide or multiply. Hopefully you remember, top and bottom divide. When we have this triangle, top dog goes in the house. So 5.6 goes in the house and 4.0 goes outside. We need to move the decimals over to make our math much simpler. 4.0, 5.6, move that decimal over after the 0 and after the 6, bringing your decimal up on top of the house. Now you have 56 divided by 40. Well, how many times does 40 go into 56? Just once. 1 times 40 is 40. 56 minus 40 leaves us with 16. Now we need to bring down a 0. We'll bring a 0 down, which gives us 160. 40 times 4 equals 160. 160 minus 160 leaves us with 0 remaining. So we have our answer for trial 1, which is 1.4 meters per second. But they're asking us for average speed, so we need to look at trial 2 as well. Same process, start with our triangle. Trial 2, solving for speed. Time, 5 seconds. Distance, 7 meters. Top dog goes in the house, so 7 goes inside the house. We are dividing 7 by 5. We need to move those decimal places over. Now we have 70 divided by 50. How many times can 50 go into 70? Just once. 1 times 50 is 50. And 70 minus 50 leaves us with 20 left over. Now we need to bring that 0 down, which makes it 200. And 50 goes into 200 how many times? Well, 50 times 2 is 100. And 100 plus 100 is 200. So we have 50 times 4 is 200, leaving us with 0 remaining. So yet again, our trial came out to 1.4 meters per second. It's asking us for average speed. Now when we are solving for an average of trials, we add and then we divide by the number of trials. But our two numbers are the same. So our average should be the same as the two numbers. And we can check it with math. 1.4 plus 1.4 divided by 2 equals 2.8 divided by 2, which ends up being 1.4. So our answer is going to be 1.4 meters per second. And we need to bubble that in on the Scantron. Now with your science Scantrons, don't forget the decimal does not float. It stays where it is. So you're going to put your 1 right in front of the decimal and your 4 right after the decimal. Go ahead and practice filling in these gridables because they can be tricky. There is number 1 for you. Make sure you copy down all of this work. And remember that on the Science Star, you do not get a calculator, so you've got to practice doing this math without a calculator. All right, let's go to number 2 and I'll help you set up. Number 2 is a concept question. It's asking you what is the difference between the velocity and the speed of an object. They're looking at what is the velocity and what is the speed. What you need to know for this question is definitions. Your hint, look at the definitions we just took in your notes. That's really all you need for number 2. Just work with your partner to solve that one. For number 3, we have 3 vehicles shown below, and they are all traveling at a speed of 15 meters per second. But only the pickup truck has a changing velocity. The pickup truck has a changing velocity because the pickup truck... This is an extremely popular question on tests like the STAR. They love to use these examples of cars on racetracks or cars on a road. So we are looking at speed and changing velocity. It tells us that the pickup is the only one with a changing velocity. They're all going a constant speed of 15 meters per second, but only the pickup truck is changing its velocity. I want you to remember that velocity is speed plus direction when you're trying to solve why the pickup truck has a changing velocity. All right, and number 4, to set it up, we have a student who walks 2 kilometers in 30 minutes. What is the student's average speed in kilometers per hour? Record your answer and fill in the bubbles on your answer document. Be sure to use the correct place value. So they give us distance and time with 2 kilometers as our distance and 30 minutes as our time. And they're wanting to know the average speed. But the tough part with this question is they're asking for it in kilometers per hour. We need to make sure our units match. Kilometers and kilometers match, but minutes and hours do not. So we're going to have to convert 30 minutes to hours. Well, 1 hour is 60 minutes, and 30 minutes is half an hour. So our new time is going to be 0.5 hours. We need to use our STD triangle to set this up. Using your D of 2 kilometers and your T of 30 minutes. But remember, We changed 30 minutes to 0.5 hours. So when you enter it into your triangle, use 0.5. And don't forget, top and bottom divide, side by side multiply. Go ahead and work with your partner to solve these 3 problems. Good luck.